Good morning, everyone. So today's lesson is over the Pythagorean theorem, and let's get started. So the Pythagorean theorem is a theorem that can only be used for a right triangle. So remember that looks like this. Excuse my drawing. It has to have a right angle there. So in that right triangle, the square of the length of the hypotenuse is equal to the sum of the squares of the lengths of the legs. Okay, so who are the legs and who is the hypotenuse on this triangle? There's only 3 sides in any triangle. So the hypotenuse is the most important one because it is the longest side, has the greatest length. So across from this right angle is your hypotenuse. I'm going to abbreviate. And then the other 2 are the legs. Hopefully it starts to look familiar. And it doesn't matter which leg you choose. They're both the legs, okay? And then let's write our equation. So the Pythagorean theorem is based off this equation. A squared plus b squared equals c squared, okay? And I might post another video explaining this theorem, why that equation exists. If you're interested in that, I'll post that probably tomorrow. But that is the equation. Now, how do we know who's A, who's B, who's C in the triangle? Maybe you're starting to remember. Again, I said the hypotenuse is the most important. You can't mess that one up because then your equation won't work or you won't get the answer correct. So the hypotenuse is always C. It's going to be that diagonal length across from the 90 degrees. And then A and B. Now, this is very important. It does not matter what you choose for A or B as long as they're both legs. So you could choose this A or B on the sides, okay? For time purposes, we are not going to fill this in. So let's move forward. The next question is this a right triangle? How would we know? Well, if we applied the Pythagorean theorem and it works, then it's a right triangle. Because right now, I don't see that right angle identifying little box that we usually have, like up here. So you cannot assume that it's a right triangle. But we can use the theorem and figure out if it is or not. So let's see if it works. Again, here's the equation. A squared plus b squared equals c squared. Make sure you have enough room there. All right, so think about it. Who's A, who's B, who's C, based on the lengths of that triangle? I have 18, 80, and 82. For sure, 82 has to be C because that's the longest side. And I'll show you that you can pick B here and A here. If you want to pick A for 18, that's fine if you like that format. But it wouldn't matter. So let's double check that this works. For A, we're going to choose 80 squared. Let's plug in our values. For B, that's 18 squared. And then 82 squared. Okay, so let's remember what we're doing. The question is asking, is this a right triangle? If it is, then the Pythagorean theorem is going to work. Okay, so this is where you would get your calculator and you can figure out those values. So 80 squared. And if you like Desmos, I would just open up a tab on the side and let it help you. And then 18 squared. $324. And 82 squared. 6,724. Okay. Now, whatever is on the left, remember when we're working with equations, whatever is on the left has to match whatever is on the right. It has to be balanced. So we need to add those two on the left. 6,400 plus 324. And now we can see that it is equal to the hypotenuse squared, which was 82. So the two legs squared plus the hypotenuse squared are equal. So is it a right triangle? Yes, it is. Okay. Now, this is 10th grade geometry, so it's not going to be that easy. For geometry in 10th grade, most likely you'll have one of these sides that are missing. So we had all the three sides, right? 1, 2, 3. We knew the length for each one. We plugged each one in, and we just said, yes, it works. For geometry in 10th grade, you'll be missing one of the sides, whether it's A, B, or C. That's our job to find out and solve for the missing side, okay? And we are also going to skip this. So let's go forward and skip that. Actually, I want to move to a problem that is about the Pythagorean theorem. So yeah, this one. Let's do this one together. So in class, we did this one together. It says, find the missing length, leave in simplest radical form. So this is one part of the problem, finding the missing length. And then the second part is leaving the answer in radical form. Okay, so let's start with the first part. Find the missing length. So here I have a right triangle, and I know it's a right triangle because it has a little box here. Okay. Who is A, who's B, who's C? The longest side across the 90 degrees is always C. That's your hypotenuse. And then the legs are the other two. So that is A and B. So here's the equation. Now, this is an equation, so we got to turn on our solving skills and strategies. We know what A is. A is 10. But remember, you got to follow an equation like it's a recipe, okay? Exactly how it is, that's how you need to write it down and be organized with your work, okay? So I'm going to use parentheses just so you can see where I'm plugging it in. 10 squared plus 10 squared should equal. If we don't know the value of something, we use x, okay? X squared. All right. And let's solve. So on the left, we have some integers that we need to simplify. 10 squared and 10 squared. 10 squared is 100 plus another 100. 200. Now remember, if you can skip some steps, I'm okay with that, but be organized. Don't lose your equal sign and don't lose the x squared or your x, okay? So this is where most of my students throughout the day got stuck, which is okay. What do we do next? How do we finish this? Remember, when you're solving for x, you need to undo everything that is being done on top of it. So right now, I'm squaring this x. If you read this out loud, it says x squared. And that can't be there. We need to get rid of it. So what is the opposite operation of squaring? It is square rooting. Just like the opposite of adding is subtracting. The opposite of multiplying is dividing. The opposite of squaring is square rooting. And that allows me to cancel the squared. And now it's left as just x is equal to the square root of 200. Okay, so all of this was the stuff in this teal highlight. So we solved for x here. We isolated it, we solved for it, and x is alone. But what does the second part say? Leave your answer in simplest radical form. So the square root of 200 equals x is not simplified. We have to simplify it, and that's where the perfect squares come in. That's why I wrote them here on the side. So this was the lesson we did before this, okay? So we got to use those skills. If you haven't seen that video, go back and watch it if you were absent. And fill in your notes, okay? Which largest perfect square will divide into 200? Out of all these, it's going to be 100. 100 times what? We should all know this. 100 times 2 is 200, right? Okay, separate it. We already did this. We should start getting better at this. Square root of 100 is 10. The 2 stays inside because it is not a perfect square and it does not have factors that will simplify. And that's it. Okay. We're not going to do this one. Let's do this one. Actually, you're doing this one. So, set up your equation. And try it out, okay? Press pause and try to do this one on your own. And then come back and check your work, okay? All right, hopefully you attempted the problem. I'm going to work it out and then just check your work. If you see something that you made a mistake on, just erase it and fix it, okay? It's okay. All right. And I'm not going to talk on this one. Just the only thing I'm going to say is that if you picked B here and A here, or A here and B here, it doesn't matter. You should still have the same answer, okay? All right, so just watch. Okay, check that you did that first step right. Okay. Hopefully you were able to get to at least half of this problem. Remember that when we're doing these, we cannot leave our answer in unless it's simplified. So over here, I simplified the square root of 200, and here I simplified the square root of 99. 9 is the largest perfect square that will divide into 99. Separate it, and then you get 3. If you got stuck in the other part of the problem, where we solved for x up here, just double check your work, okay? And that is it for today. Oh, sorry, I forgot this one. Okay, this one is easy. The cat is stuck in a tree. How far up is the cat stuck? 16 feet off the ground. Let's draw a picture. Oops. 16 feet off the ground. This cat is stuck up here on a tree. I'm just going to write the word cat because I don't know how to draw a cat. if you were in class today, then you saw my drawing, not my drawing, my picture, but I didn't draw it. It says the firefighters are going to use a 20-foot ladder, and they want to know how far away the tree, how far away from the tree should the ladder sit so it exactly reaches the cat. Oh my God. No, I don't know how to read. Find the missing side length. So here's the ladder. Okay, that's not straight. Here's the ladder. And the ladder is 20 feet. And then we want to know how far from the ground does it need to reach the tree. From the bottom of the ladder down here. So here's the ladder. And this creates a right triangle. And so if this is the length we need to know, then this is x. Okay? So try to set up your equation. Okay? Across from the 90, that's C. This could be A and B. Okay? Go ahead and try to do it on your own, and then check your work. Okay? This one should be a pretty answer. All right, come check your work. Keep it balanced. All right. We are done with the notes. Make sure that you start the practice worksheet. And I will make another video for those problems, okay? But it'll probably be a day after we do it. Not the day of, obviously, because you need to try to do it on your own. So yeah, glue your notes in your notebook and then come see me if you still need help or if you're confused. Thank you.